okay, definition-wise telling us, we write this equation, okay, limit of f of x when x approaches to a equals L, and we say it, the limit of f of x as x approaches a equals L. Okay, so later you have to know how to read it, okay? The limit of function f of x when x approaches a equals L, okay? If we can make the value of f of x or the value of y arbitrarily close to what? L, okay? Well, as close as to L, okay? Or arbitrarily close to L, it's the same thing, okay? So this is the same thing as this. By taking x to be what? Sufficiently close to what? Close to a, okay? On either side of a, but not equals to a, okay? So here, when we say x approaches a means x will be sufficiently close to a on either side, means either from the left or from the right, but what? Not equals a. We don't care when x equals a, f of a, whether f of a exists or not, or equals a different value other than L, we don't care. We only care about what? When x is very, very close to a from both sides, what will be the y value get close to which value? You guys, okay? So this is the key, okay? This is the key for the limits, okay? Limit means what? It's not exactly f of a. It's the y value when x is very, very close to a from both sides. Okay, you guys? Alright, and from the previous example, you can see that does f of 3 exist from this current example? What is the value for f of 3?
There's no value.
There's no value means what? There's an open circle means what? F of 3 doesn't exist.
It's undefined.
Undefined, or we don't know. Okay, we don't know. However, we can see that the limit of f of x when x approaches to 3 still exists, and it equals what? 2. Okay, see? We only care about when x is close to 3, but not exactly equals when x equals 3. Okay? Alright, so ultimate notation. Usually we don't, sometimes we write an equation like this, okay? Sometimes we just say f of x approaches to L as x approaches to a, okay? Which is read by blah blah this, okay? F of x approaches L as x approaches to a, okay? Okay, here, this is a remark, okay? Well, in finding the limit of f of x, okay, we never consider x equals a. In fact, f of x need not even be defined when x equals a. The only thing matter is what? How f is defined near a, but not equals a. You guys? Okay, so we have all of the three cases, okay? So all of the three cases give us what? Limit of f of x when x approaches a equals L. Okay, so let's look at these three cases, okay? Let me redraw them, okay? Now let's look at the first case, guys. The first case, this is a curve, okay? This is a value L for y, okay? And we can see that from this case, okay, from this first case A, okay, case A, we know that when x approaches A from the left, the y value approaches to what? L, right? And then when x approaches A from the right, the y value approaches to what? L. How about when x equals A? Yes, f of A also what? Equals L, right? So this is this case. This case gives us this limit. How about the second case? What's the difference between the second case and the first case? This is case B. Well, in this case, does f of A exist? It does, because we have what? We have a closed circle means f of A exists, okay? However, is this f of A value exactly equals L? No, we say it's a different value m, okay? So f of A exists. However, does f of A equals L? No, okay? But can we say this case, it does not give us this limit? Can we say that? No. From this case, we still say f of x, okay, limit of f of x when x approaches a equals what? L. Because what? Let's check. When x approaches a from the left, y value approaches to L, right? When x approaches a from the right, y value also approaches what? L. So this case also, it gave us what? The limit. Yes, it is, okay? How about the third case? What is the difference between this case?
There's no point for A.
There's no point for A?
It's just undefined.
Undefined?
That's all.
Oh, okay. Is this an open circle?
Yep.
Let me check my...
There'd be no point to close it.
Oh, okay.
Yeah.
Oh, okay. But here, I see a... This is open, right?
Yeah.
Oh, okay. Because it looks like a closed.
Well, the thing is, if it was closed, it'd just be cracked.
Yeah, I mean, what's the difference between the case C and the case B, okay? This is a case C, okay? We have an open circle here because the picture is so small, so it doesn't look very clearly, okay? But you see that there's open circle there means f of A does not exist, okay? However, we still say the limit of f of x when x approaches A equals L because when x approaches A from both sides, y value approaches to what? L. So it doesn't matter f of A exists or doesn't exist or exists and exact equals L or not, it doesn't matter. What only matters what? Is when x is close to A or near A, how f of x matters, right? You guys? Any questions? No? Okay, yeah, so this is the basic definition for limits, okay? So I hope everyone is, understand this, okay? Understand this. All right, now let's look at two examples about how to evaluate the limits, okay? So this limit is compute the limit of square root of t squared plus 9 minus 3 divided by t squared when t approaches to 0. So how can we do the problem? What is your first guess? Oh, let's plug in where, when t equals 0, let's see. If we plug in t by 0, what should we have? 0 squared is 0 plus 9 is 9. Square root of 9 is 3. 3 minus 3 is 0. Oh, so on top, if t exactly equals 0, we get a 0. And how about when t approaches to 0, when t exactly equals 0? 0 squared is what? 0. So, but, when we come to the limit, we don't use t equals 0 directly. Okay. However, if we use t approaches to 0, when t approaches 0, t squared will approaches to 0, right? Approaches, okay? I'm not saying exactly, okay? So just like we use t equals 0, but we don't have to do that. We cannot do that because limit, we don't care about when t equals 0, what we will have, right? So when t approaches 0, we can see that the top part will approaches to 0. And how about the bottom part? Also approaches to 0 because 0 squared will approaches to 0. So we still have a 0 over 0. So can we say that there's no way to compute this limit? Well, there are two ways to do it.
Can you choose two numbers on either side and compute it?
Yeah, so far the most direct way is because we're talking about, say this is t-axis, this is f of t-axis, okay? Because we talk about when t goes to 0 from each side, okay? So the method one, I would say the method one is just to choose values that are very close to 0 from both sides and compute those values, okay? Compute the y values. So we can make chart like choose t values, get very, very close to 0 from the left, okay? So we know that from the left of 0, we may have negative 1, but negative 1 is too far away from 0, right? So can we choose a close one like a negative 0.1? And then we know negative 0.01 will be even closer to 0, right? Or we can choose negative 0.001, right? So these are the values are getting to 0 from the left. Guys, do you see that? And then what do? Use your calculator, guys. Plug in when t equals negative 0.1 and then compute this result, okay? I'm going to use a square paper. So you're gonna use a calculator and then do calculation, guys, okay? Let's see how we do it, okay? Plug in when t equals negative 0.1, that's what we can do so far, method 1, okay, is when t equals negative 0.1, it is negative 0.1 square, okay? And then plus 9 minus 3 divided by negative 0.1 square. Use your calculator and then tell me a briefly number, okay? Yeah, well, approximate number. I want to say round it to the thousands or hundreds or whatever, okay? Or even more digits, depends on the result. And then negative 0.1 square. Since we use the parentheses, it's the same thing as negative 0.1 times negative 0.1. It should be the same as 0.1 square, right? So 0.1 square gives us 0.01 plus 9, and the square root minus 3 divided by 0.01. Has anybody got a result here?
0.1667.
Okay, 0.1667, right?
Yeah.
I'll write on whatever you tell me, okay? Okay, so this is when t equals negative 0.1. It's close to 0, but this number is even closer, right? So what I want you to do is replace the t by negative 0.01. So negative 0.01 square gives us 0.0001 plus 9 square root minus 3 divided by 0.0001. What do you get, Dakota?
I already know what it is.
Okay. How about you guys who are using the calculator?
Yes.
This is the most direct way, okay? Because we just learned about how to compute limits, and then we just make sure that the t-value is very, very close to 0, and then we keep on trying.
There should be 0.1666, and it runs on.
Okay, so more 6, right? So how many 6? 3, right?
That's a fraction.
Yeah. So I would say since, how about you guys?
By the way, I actually took it to more decimals. If you want to keep carrying the top number on, it goes 6667.
Okay.
So it is very slightly larger.
1.16667, right?
No, 1.667.
Okay, 1.667, right? Still this one, right?
Sorry.
Yeah. How about this one? There are more 6, right? There are more 6, right?
1.6667.
6.
4 6s and a 7.
Okay. See, there are what? More 6, okay? And you can try this, okay? You can try this, but I'm going to tell you that there will be more 6s in between, okay? 6, 6, 6, 6, I don't know how many. I'm going to guess there will be 6, 6, okay? And then 7, I don't know, okay? But guys, can you see the pattern? When t approaches to 0, what is this number getting close to? Point what? 1.66666. If you don't run, it's going to be keep on, repeat. 6 is keep repeating. Okay. What is this decimal number getting close to in a fraction?
1/6.
1/6. Okay, 1/6. So we can guess. Oh, when t goes to 0 from the left, this result, this whole fraction will goes to what? 1/6. Okay, so when t goes to 0 from the left, okay, we'll talk about the left limit and right hand limit very soon. Okay, this means goes to 0 from the left. Okay, this whole function will goes to what? Getting close to 1/6 as a fraction. Okay, so this is from the right, from the left of 0. Okay, same thing here. I don't want to repeat it. Okay, if we have t values, okay, which is 0.1 here, close to 0, you can try 0.01, which is more close to 0, and then 0.001, or you can try more. Okay, we'll see.
I'm going to stop you right there.
Sure.
Because it's t squared, so it doesn't matter.
Right.
You're going to get the same result.
Yes. See, when t equals 0.1, okay, and when we plug in here by 0.1, yeah. So I or just copy whatever, very good suggestion. Point is 1667, okay? This is going to be exactly this, right? Point 166667. This is going to be point 1666667, okay? So we can see the pattern is the same thing. When t goes to 0 from the right, we use a plus sign on the top right, means this is, when t goes to a number from the right, okay? How about this whole function goes to? Still goes to a fraction 1/6, okay? So can you guess the result for this limit? It is going to be what? It's not 0 over 0. It's not equals, approaches to 0 over 0. It equals what? 1 over 6. We say equals means when t is very, very close to 0, this y value will be very, very close to what? 1 over 6. Okay? And then when t equals 0, is this function defined? It doesn't even define, right? What is 0 over 0? We don't know, okay? Well, we don't care when t equals 0. We don't care. We only care when t approaches to 0 from both sides. You guys, that's good for computer limit questions the most directly, but do you like it?
Well, I was simple on the next one.
Can you actually do method 2?
Yes. Now I'm going to try to show you the method 2, okay, method 2. Because method 1 is kind of tedious, very tedious, okay? So I will show you the method 2, okay? You can use either way, okay? Well, hold on 1 second, let me put this under here, okay? We want to compute this limit, okay? So just now we get what? A 0 over 0 when t approaches to 0, right? But we know that the result we got is 1/6. And how can we use a more specific algebraic way to get the limits, okay? So here is method 2, okay? We copy the question limit when t goes to 0, square root of t squared plus 9 minus 3 over t squared. Okay, so let's see how can we do it directly without approximation. Okay, so see guys, on the top under the square root we have a square root of t squared plus 9. We also have a 3 there. On the bottom we have a t squared. So do you still remember the concept about conjugate? You still remember the concept about conjugate? I'm going to write it here, okay? What's a pair of conjugates? Say we have square root a minus square root of b. What is the conjugate of this expression? If you forgot, that's fine. I say square root a plus square root b is a conjugate of this. Or you can say square root a minus square root b is a conjugate of square root a plus square root b. It's a pair of conjugates. So when we have a pair of conjugates, guys, and we multiply them up, what can we get?
That's just the original.
Either you can for you, this for you, in case some of you guys forget, okay? So once we for you, square root a times square root a give us what? A, because square root a square is a, right? Then square root a times square root b, square root a times b. For you this give us negative square root of b times a times b, and then minus what? What's square root of b times square root of b? B, right? And these two terms, can we cancel them out? Yes, we are, okay? So eventually, do we have any radical expressions anymore? No radicals, right? So that's how we use these pairs of the conjugate and multiply by, together, and we don't have the radical expression anymore, okay? Now guys, I hope you guys copied this, okay? Let's go back to our question. Hopefully this gives you some hint about how to solve our problem. We have a square root of t squared plus 9 minus 3. I'm asking you, what is the conjugate of this whole numerator? This is something minus 3. So the conjugate should be what? This something plus what? 3. Can we? Okay. So what's the difference between the conjugates? Is the same expression, okay? One is minus by the other one's plus by the other, okay? So I would say we're going to multiply the numerator, which is t squared plus 9 minus 3, by its conjugate. What is conjugate? Square root of t squared plus 9 plus 3. Okay, so we multiply the conjugate to the top. Can we just multiply the conjugate to the top? We have to do so to the what? Denominator, okay? So what is the denominator? T squared. So what we do for this step is we multiply the conjugate of the numerator, which is this, to both of the numerator and denominator. Okay? Let's see what we will have on the top, guys. Square root of a minus square root of b plus square root of a plus square root of b. Well, the result is what? A minus b, right? No radical expressions. Or we say a is the square of square root of a, b is what? The square of the square root of b, right? So if we multiply these two up, what can we get? If you are not sure, you can use what? Value. Well, I will just use the conclusion from the previous directly, okay? I will say
It's going to be t squared
plus 9, no,
minus 9.
minus 9. Why 9? Because 3 squared give us what? Very good. This is a key step for us, okay? Everybody agree with Simon? Alright, on the bottom, what do we have? T squared times square root of t squared plus 9 plus 3. Okay? Alright. What do we have on the top? What's 9 minus 9? Gone. So we have a t squared over t squared times by this parenthesis, right? Now, guys, how can we simplify the t squared over t squared? Can we cancel the t squared? Yes. Well, when can we do it, guys? When t cannot be 0. If t equals 0, we cannot cancel out, okay? We're not canceling out 0 over 0. We cannot do that. Only when we have non-zero top and the bottom, we can do it. But in this case, will t equal 0? No, because t approaches to 0. So yes, it's very safe for us to cancel the t squared. Because when t squared goes to 0, t squared does not equal 0. So we cancel out the t squared, okay? T goes to 0. On the top we have 1. On the bottom we have a square root of t squared plus 9 plus 3. So let's see, guys, what can we have? When t approaches to 0 this time, t squared approaches to 0 plus 9 square root of 9, 3, right? 3 plus 3 is what? 6. 1, 6. You guys?
Could you repeat that last step?
Okay, when t approaches to 0, okay, so when t approaches to 0, how about t squared? T squared will approaches to 0 because 0 squared is 0.
I see.
And then if this part is 0, 0 plus 9 give us 9, and the square root of 9 give us 3, plus this 3 give us the 6. Right?
I have one more question. Why is it that when you divided it by t squared plus 9, it turned into 1 and not 0 at the top in the numerators?
Because when you divide a number by itself, it's 1.
So ours t squared plus 9 minus 9, so 9 minus 9 is 5.
Simon, what's 5 over 5? 1 over 1. It's not 0 over 0, right? It's 1 over 1. So that's why, because t squared equals t squared. So if we divide by t squared from the top, we get 1. If we divide the t squared from the bottom, we also get we should reduce to be a 1.
Okay, I understand.
Yeah, good. Okay. Alright guys, so see for the same limited questions, we use the 2 method to do it. Everybody feel comfortable about this problem? Well, so far, okay, I did most most of you guys are more familiar with this, okay? This is the most direct way. But when you do enough practice, most of you guys should be more comfortable with the second method, okay?